In this video, I will walk through and work through some game of chance examples. These examples will include multiple events, combinations, and binomial probability. Your task at the end of this is going to be to construct your own game, being creative with the topic or the theme and using one of these different types of examples. Just basic or simple probability of like rolling a die one time or drawing one card from a deck will not work for these games of chance. So the first example here, this one is using multiple events. In this game, the player will draw a card from a collection of 10 years, 2011 to 2020. So there are 10 cards there. The player will then draw a card from a collection of 7 different cards labeled Springfield, St. Mary's, CMC St. Mary's, GFW, GFW Springfield, MVL, and MVL New Ulm Cathedral Springfield. As you can see, there were years when there were co-champions and also tri-champions. The goal will be to match the year with the team or teams that won or tied for the conference championship that year. The grand prize will be picking the year 2020 and MVL New Ulm Cathedral Springfield card. Second place will be picking 2015 and GFW Springfield card. Picking a Springfield-only match will win their money back. Realize that Springfield won multiple years, and those will be on the next screen. The game should be designed for an expected value of negative 0.20, which means the player will lose on the average 20 cents for every dollar they play. So these are the years in their championships. 2011 Springfield won. If that match is picked, they would receive their money back. So if they pay $1, they would get $1 back. Net profit there is 0. 2012 is St. Mary's, 2013 CMC St. Mary's, 2014 GFW. Those 3 years, since they don't involve Springfield, even if you do match them, would be losers. In 2015, GFW Springfield were co-champions. This will be second place money. 2016 is MVL, no prize, a loss. 2017, 2018, 2019, Springfield also won. They would receive their money back. In 2020, we had the tri-champions, and that would be the grand prize. So in working out this example as we did in before, we will have events, the gain-loss, and the probability of each one. So our first event would be the 2020 year with the MVL New Ulm Cathedral Springfield card. The gain-loss, this is a grand prize. At this point, we're just going to be guessing, basically. So I'm just going to put $20 on this one. And then to calculate the probability of this is multiple events, so they would be selecting the 2020 card, which they have a 1 out of 10 chance of doing that. There's 10 cards, and they need that 1. Choosing the MVL New Ulm Cathedral Springfield card, there are 7 different team cards, and that's only 1 of those. We would multiply them, and so this probability is 1 out of 70. The second event would be the 2015 year and the GFW Springfield card. I'm just going to set this as a winner of $10. Again, I'm just guessing approximately. To pick the 2015 card, that's a 1 out of 10 chance. To pick the GFW Springfield cards, 1 out of 7. Multiply. This also has a probability of 1 out of 70. The third one is your money back. So this is the year, which could have been either 11, 17, 18, or 19, and to choose Springfield only. This one's going to win their money back, so I'm going to have this be a 0. So they're paying $1, getting their $1 back. So to pick one of those 4 years, that probably would be 4 out of 10. To pick Springfield would be 1 out of 7. So this probability would be 4 out of 70. And the other event would be something else, which would be the losers in this example. They're going to lose $1. To determine this, you could calculate all the different types of probabilities, but the easiest way when you get to this point is, say, in this case, I have 6 out of 70 winners, the 1 out of 70 plus 1 out of 70 plus 4 out of 70. 6 out of 70 chances to win, so there would be 64 out of 70 chances to lose. Calculating this expected value. So here's where we do our gain-loss times our probability and add each of these up. So I would have 20 out of 70 plus 10 out of 70 plus 0 minus 64 out of 70. Adding these up, I get a negative 34 out of 70, which is a negative 0.48. Somewhere around the negative 0.49. Now what this means is that the players would be losing about 50 cents every time they play. We want this to be as close to negative 0.2 as possible. Therefore, I need to make some changes. I'm not going to change the way the game. All I'm going to do is I need to add more winnings into it. They need to win more money. Okay, so for example, the only thing I need to do is change the prize money for 2015 and 2020. So in doing this, I could change the 2020 to, let's say, a gain-loss of $30. Probability is still 1 out of 70. And I could change the 2015 winner to $20. That still has a probability of 1 out of 70. The only thing that changes is when we do expected value, this is now 30 out of 70. This is 20 out of 70. So I have 50 out of 70 minus 14 out of 70, which comes out to be a negative 14 out of 70. Which comes out to be exactly negative 0.2. And that is what our goal would be. Now, this example came out perfectly, works out good. It doesn't always come out to be that easy. But you could definitely be lucky enough to get that as soon as we did. I'm going to stop this video and create another one now with some combination examples and binomial distribution.